close the door. Thank you. Okay, so thank you. Welcome. Let's see if this can work. Yeah. Okay. And well, let's start. So welcome to the session. This session is a. Okay. It doesn't work. Come on. Okay. Yeah. So this session is about some experience that we have done testing what happens if we put on Kubernetes, on our operator, PXE operator, from 1 terabyte up to 10 terabytes. And our intention was just to have the most boring situation ever. So our scope was to be able to have no surprise, and if it's possible, no issues, because that will prove that actually you can scale without having to spend your, the night awake to fix things. Okay, this is me. I'm open source Marco Tusa, open source enthusiast. I work in this field for a very long time. I'm very old, thank you. And I love the community and whatever is related, and the pointer is working again. Okay. And let's go ahead. So our goal, as I said, was to validate that we can reach that limit. And in this presentation, I keep things at very high level. I need to be honest. I don't dig into very deep. Also because that will be done by Nando in the next presentation, because that has been a completely different one and very. So we decide to keep the two things separated. To do this test, we decide to use, as I said, our solution of the operator, so the MySQL PXE operator, written by some of the people that is also here, like Ege and others that are here. Can you stand up 1 second just to let you recognize? So they know you are the culprit. Okay. Thank you. Just, And then we decide, okay, what can be the most used platform in terms of, and we decided AWS. Now, the problem was that to be able to scale, you need to also have some kind of large machine with storage guaranteed in terms of IOPS and so on and so forth. And we have to go through this kind of type machine, 16 large, 64 CPU, and the storage was block express volume provision at 80,000 IOPS. Spent a lot of money, yes, and my manager was not, our manager was not happy about it, and so, but yeah, it was worth it. And for this presentation, we have identified 5 parts, which is the steps that we have done. Again, this is not about performance, it's about operations. And what happened is how build, right? How you start and build the cluster, so starting from the snapshot. Then what happened when you do simple schema modification, like table part? Oh, no, partition is not reported here because it is a long discussion there. So we are going to start. But modification like DDL, index, and other things. Then simple data export import and node recovery. This case is interesting. Node recovery and the cluster resilience. So what happened when you lose the cluster and need to recover from one node. And then simple backup and restore. I just mentioned something about performance because it comes with a simple issue that we identify, and I want to mention, but it's nothing compared to what Nando did after. So the snapshot and the cluster startup. Oh, you see how cool the image that AI is doing, right? I love this kind of things. Before you were spending days trying to identify what could be done. Okay, this scenario was done building the 3 different dimensions, so 1 terabyte, 5 terabytes, and 10 terabytes. Then you build the schema, you fill the data, then you take the snapshot and you represent the snapshot to the Kubernetes, to the pods. And to simplify the things, what we have done is to present all the different volume snapshot class and volume snapshot and to the PDC before starting the cluster, but in a lazy mode. So nothing was really loaded, nothing was really mounted until the pod starts. Okay. And yeah, we have the same kind of schema, but with different dimension in terms of rows. So this is what happened. Of course, we start with the initial snapshot, and you need to think about it, right? When you are in standard environment, you have your snapshot, you present your snapshot, you start your instance, and normally that is almost instantaneously able to go, right? And when you do that with multiple nodes, it is able to fastly catch up. Well, this actually is something that don't work like that. When you do a single node, you see the difference between the data is very limited. But then, if you do that for the whole cluster, and here the time is taken from the moment that you start the first node to the moment that the last node is declared ready. So everything needs to be up and accessible, okay? The time that is taken is huge, of course. So why? Because in any case, the cluster has to go, because the snapshot itself has to go through different validation from the Gcache that is there to the data that has to be reanalyzed. It happens that you have this large amount of time that is changing, well, climbing from one single node to the whole cluster. This is something that actually is already a difference with the standard on iron situation. But the data integrity was okay. Sorry, those are very verbose slides, and I apologize for that, but I'm old, and I tend to forget things. So it helped me also to remind, what to say. So yeah, we said data integrity, everything was at the end available. The problem was the performance. And then we also have another issue. The issue that this is open a bug that the guys in we need to work on that, is that obviously if you use the snapshot, the snapshot has the image of that machine when you take it, right? So the UED file that is in the data directory is the same, and in order to remove the pod starts, it recognizes the UED, the nodes try to join the cluster, the UED is the same, you cannot have the same UED, so the node needs to be stopped, clean up the UED and restart. And that adds some significant time in the graph that we saw before. So this is something that we are going to fix. The other point is that, as I said, the value is, the time is taken from the first node to the last node when everything is up and running. So given the fact that we have HAProxy, what you are doing is querying the HAProxy. And what happened is that during the pod starts, HAProxy say, oh, okay, yeah, I can access. And say, okay, I'm ready. Then immediately after, no, sorry, I'm still in the middle of restarting, and stops serving. And that creates a little bit of noise and to the process. We need to clean up this as well, because of course, if you have any monitoring on that, it will be problematic. Okay, schema modification. Any question on that first part? Yeah.
With the cluster, was the performance issue related to the volumes hydrating from the snapshot?
Yeah. And actually, this is, I'm sorry I don't have Chetan here, that is our Kubernetes mega expert that spoke with AWS folks because that is what AWS will say. Yes, we know there is a problem there, and we are trying to resolve it, but that is how actually works at the moment, that the snapshot have this kind of issues.
You could argue then that the single node test wasn't the same.
Exactly, but the problem apparently, I have no details on that, but the problem apparently is on AWS side, how they restore and represent the volume of the snapshot and re-prepare the snapshot after you have just one. I'm sorry, I don't have more detail on that. If you want.
No, I understand the issue.
But you have. Because
it's just the way the snapshots work.
Well, yeah, but when you prepare once, it should be faster also on the others, right?
Not if you're provisioning a new volume from the same snapshot.
Okay, but yeah, okay, let's talk after, because that conflicts a little bit with another experience that we have, but okay. So, schema modification, okay, you can do some changes using instant, but our scope here was to instead have a situation where you have to change things in a way that is a little bit more impactful. So we don't use instant, and you have to remember that in our case we are using TOI, so total order isolation, which means that if you start a change and alter, you cannot really interrupt that alter, right? That alter is gone. I mean, there is no way to kill it. And so you need to represent the most impactful scenario. And this, again, and the test was done, no traffic and some traffic, not huge, just some traffic. And of course, you can see that when we have some SQL traffic, there was a lock, so everything was actually not working if you use directly SQL. But if you use Percona online schema change, of course, you can do whatever you want. So this is nothing different from the standard situation that you are operating. So in this case, we are 101. We know that. The only difference is that you can use instead TOI, right, which allow you to do changes in one node, then in another, but that it doesn't really make any difference in how the DDL impact the cluster and how you can operate. So the interesting part here is also the way that with Percona online schema change, of course you have more data. You need to duplicate the table because it's an exercise of duplicating the table, keeping the change in the new table that you have, and then swapping the table at the end. So of course, more data, more time. And nothing new. That's what we have in the standard environment. And same thing with the index is almost the same thing with data increasing with the operation, but again, nothing different from what we were expecting on Iron. And the only difference is that in this case, for dropping in index now is cheap, so you can eventually do that directly without having to go to the Percona online schema change.
Marco?
Yeah.
On the previous slide about dropping a column with SQL with traffic, like some of those operations are instant, no?
Yeah, I know, but I said we know that you can have an instant operation, right? But if you have an instant operation, and that will be, and during the replication phase you have a crash on the node, everything is going to be logged.
Okay.
And so this is why I'm saying, I know there are some operations that could be instant, but we are considering the most impactful part of the operation.
Okay. And the time spent you're considering once the operation started, not waiting for logs.
From the operation starting to operation ending. So it's of course, with traffic you have logs. If you don't have traffic, you don't have log. I mean, the table is locked, but there is no traffic, nothing happened. But yeah, so it's from start to the end. And yeah, everything works as usual, no criticalities. The only problem that we currently have here is that we recommend to use Percona online schema change for this kind of operations because, again, it allows you to operate in a way that is controlled, because if you need to stop for any reason the alter, if you launch the alter with standard SQL, you will not be able to. If you do that with Percona schema change, online schema change, it will be possible. And I remind you, this is not standard on Iron, is Kubernetes with pods. So if something goes south, the risk to have the full cluster down is high. So this is why also we are trying to avoid to simplify, to try shortcuts like Easter, because that could be one of the problems you have. You think you're safe, something goes south, and you are in the worst position ever. This is a very simple test. What we were trying to do is to export the data from a table and re-import the data to a table and see what time is taking. Any problem in doing this kind of operation, and to do that we use my dumper, my loader, and the MySQL shell utilities with some load and without some load. Of course, again, no surprise. We have the 10 terabytes that is taking longer, and actually my dumper in this case was performing a little bit better than MySQL shell because the table cannot be multi-threaded, right? When you export, while my dumper can multi-thread the table, so it's more efficient. We know that is a limitation. It's something that was already there. There are one no surprise, as I said. So we can confidently use the same way, same approach, same methodology, same script that we normally use to do this kind of operation on Iron. Also, when you use the solution using Kubernetes and the operator. And the only problem that, of course, we have is we have two, actually. One is one problem that happened once while with MySQL shell pushing to S3, and the other one is that my dumper doesn't have any support for streaming directly, so you have to write your own things around that. Okay, this is a little bit more interesting. I told you, we hope for boring. Because we really want to have the same situation that we have on Iron. But in this case, no. We have a significant difference. Okay, how that test was done? The test was done, we have the cluster, then for some reason, the nodes start to fail on cascade. And this is not something that I created. Happened for real on a customer. So what we were trying to identify is, okay, exactly what is the impact of it if the data instead being 200 gigabytes is 10 terabytes, for instance, right? And again, the full capacity, we have two ways of identifying the availability here. One is when you have node 1, so you have node 0, node 1, node 2. Once you have node 1 up and running, which means you have the minimal level of high availability, and that that you can use eventually to restore your system, or you have full capacity. By default, we need to keep in mind that the operator goes for full capacity. Again, you confirm that, right? Don't let me say something that is not. So I need to read. I need to drink a second. Okay, so you have the crash, you restart the first pod, you restart the cluster. What happens is that node 0 is restarted, it comes up, and then node 1 is restarted. And you know, in the simple way, so single node is minimal availability. Of course, the time scale up with the dimension, but again, this is expected. And by the way, testing the two different methods with extra backup and clone. Clone has been the faster solution in all cases. And the problem was, no problem, everything was working fine. The difference is that we go for, for let's say 37 well, let's say 32 in single node with 1 terabytes up to 450. And instead with full cluster, we have, 51,900. So it's almost the double of the time. And that makes sense because you have to wait for the other nodes. What really doesn't sound right is the way that we have to wait for the full cluster. Because in case of crash like this, what you want is to be up and running as fast as you can. So what you want to have is the minimum high availability as soon as possible. In fact, if we analyze the things between what happened in traditional premises and Kubernetes operator, one of the things we have initial availability. Normally, when you have standard on premises, you consider the system already up in degraded state with node 0. Node 0 is up, and you can say, okay, at least I can start to serve the queries back. I don't have to wait for the other. Instead, in our case with the operator, we have to wait for all 3 nodes and to be sure that the class is declared healthy and ready to go, and have the HAProxy reestablish the communication. This is all things that can be, okay, let me finish, then I will say something. Same thing for the routine that is managed by operator, while in standard premises you can have solution to do that manually, and you can force. And the recovery time is fastest when you have one single node. Now, there is a way to trick this, and is to say to the operator, I have the size of the cluster is 1 node, 2 nodes, 3 nodes, and every time reload the YAML file and force the cluster to see 1 node at a time. So in this way, the service will be available doing 1 by 1. But by default, let's say, is like that. We need to work on this to be a little bit better, to be honest. In terms of backup and restore times, also there is something to say, but this is more for the way how backup works. And the exercise was done doing some traffic, of course, while we were taking the backup and then trying to restore it. And aside one interesting fact that S3 was faster than local, there is another thing, that actually a full node recovery, it takes quite a lot, which is something not uncommon also on premises. But if you, but the fact that you are using, with extra backup I'm talking. So the fact that we are using extra backup and the restore process at the end was extremely slow, not because the copy of the files, because with extra backup you have 2 moments. One is when you take the backup from S3 and you copy, and then you need to apply the redo log. Now, given the long time taken for taking the backup itself, the redo log was significant also because there was a lot of traffic there. So the apply part was also quite high. And yeah.
Is the operator using smart memory estimation? Like, I remember that I developed that when we are doing the backup, it can calculate how much memory it will be necessary to do the apply log in the most optimal. Okay, you do it.
Here we go. So the problem is that by default, the agent for the restoring has the dimension. Oh, sorry, I probably skip it because I was in rush. Where is it? Okay, no. Where is that?
100 mega.
The last one.
No, it's I don't see.
The default
Okay.
memory?
No, yeah, wait a second. Here we go. Yeah, anyhow, yeah. The default memory was 100 megabyte. Of course, cannot work, right? It cannot work. 29 hours just because that. We need to find, this is another thing that we need to work. We need to find a way to automatically do this, because that is changing the configuration of the restore such that you have a proper amount of memory. Also, if the apply is single threaded, and this is something that
Yeah, that's no workaround.
no workaround. But at least the time from 29 hours went to 22. So this is one of the, let's say, problems that have been identified while doing the simple exercise. And I love to do that because we have identified very simple things to fix, but that can align the solution to what is on premises right away. So, you know, better than I think.
Marco, is like if you go back to the slide where you have your numbers,
This one?
the previous one.
Okay.
So like take a backup, restore a backup.
Mhm.
I'm just looking at the smallest of these numbers, like local, 129 and 180 on the other side. These are significantly higher than the resync of your cluster before. Is this only because of the 100 megabyte, or there's something else?
Yeah. Because that was by default. You know, you say, okay, well, it's significantly higher, but again, in this case, it was working with 100 megabytes.
So basically, in the previous resync of the cluster, the backup and restore is done
in a different process.
Well, it's done in the MySQL container, which has a lot of memory, and here it is done
It's
the
different.
backup.
It's different. Yeah, it's different how it works. Yeah.
Okay, so that's the first
That is an
example of
SST
different-
process that actually has its own environment on the pod, and this one is an extra a backup process, so as a spin up in a different way, right? Correct?
Were these the backups to S3? Well, were they compressed?
They were compressed by default. Yes. Okay. No, I'm going back. Why I'm going back?
I'll have 10 minutes.
Yeah. Why? Sorry, guys. Something happened. Okay. Yeah. I don't think I have time for this, right? How much?
10 minutes.
10 minutes. Okay. So it's very fast. This is not a performance. It's really an abstract, and it's mainly just to show you one thing that that screwed up most of the performance test at the beginning. By the way, what I did here is sysbench 50% read and write, and what I tried to have is uniform access to the data set, which means having the ID covering the whole data set, and then simulating hot data, which is with the Pareto set, just using a subset of the data, referring to the latest ID. Okay, so this is more just to be clear what in terms of and you know, the difference, of course, as expected, we have 64 CPU, we reach the 64 CPU scaling, then we flatten the line. This is nothing new, and what you can see also is that whenever you use the Pareto, which means the hotspot data, you get a little bit more of performance because you are hitting always the time the same set, and then a little bit of losing performance. But what happened here is that analyzing the buffer pool, analyzing the pages and the server behavior, of course something was not going very well, and you can identify by the spikes you have here, here, and there. Of course, notice the difference between the level of access of when Pareto uniform in terms of the buffer pool page reads. But again, the problem here is something is not allowing the cluster to work as it should. And flow control happened. We are in PXE, nothing new, flow control happened. And analyzing, we have the node PXE1 that was creating all these flow control calls. And you know, this is something that surprising, because before doing all the tests, we test the volumes and everything was working nicely, everything was the same, but doing the performance test, at the end, one of the node, which is again node 1, start to lose performance, and that because the volume mounted, the ABS, start to be to degrade in performance itself. So at the end of the day, we have 21% performance degradation on that volume. So we have to shut down everything, stop everything, destroy the volumes, recreate everything after sometimes to have, again, a situation that was stable and equal across all the nodes. So the spike, this was a little bit upsetting because despite the one spent, I need to say, that it is not guaranteed that ABS is allowing you to sustain the traffic as
when you mentioned performance degradation, is the latency of writes or reads that?
It was, yeah, in this case was write. That the test done here is trying to complete 1,000% write, 10,000% write, and you know, just simple write and see how it goes. And you can clearly see that that volume was screwed.
So it's interesting to know it's writes because I have a patch to MySQL to like find fail latency in reads exactly for a cloud environment, and I haven't done the writes because I thought the writes were completely async and would not impact, but it
does impact.
So we also need
yes.
some
good to know, yeah, because
monitoring.
Absolutely, yes. And
because the cloud are a messy environment.
Yeah, and to be honest, this one was also discussed with AWS and say should not happen. Yeah, thanks God, should not happen.
So I've seen that quite often, like having slow writes, slow, like degraded volume like this, when a RAID event happened in,
okay. On the,
yes,
but yeah.
If their volume ends up being degraded for this, yeah. And if this is a primary, you want to fail over, but you need to be able to desync this, which is
exactly,
which is complicated.
Yeah. So yeah, let's go to the last one also because I think time is over.
5 minutes.
Yeah, but conclusion. Well, for this one, the conclusion is don't trust ABS. Go for direct attached storage as much as we can. And the most important thing is exactly that. And you know, to conclude the whole thing, to summarize, I have been skeptical about Kubernetes and stateful environment mounted on stateless environment. And inside the company, I don't know if my boss is here. My boss is here, yes, but he's not looking at me. I have been, yeah, he's distracted. I have been saying several times, this is not going to work. We are doing the wrong thing. And I participate and collaborate with the Kubernetes team just to try to be wrong. And I have to say that aside few things that we have to tweak, I was surprised. I was expecting a disaster, didn't happen. And actually it's something that could be sustained and monitored with the right tooling, with the, as you were saying, is we need to tune exactly the things and observe correctly the different aspects. But it could be done, and it doesn't change too much the way we work, which is the most important thing, because you don't want to reinvent all your platforms, all your monitoring, all your way of doing to just adapt the work to a different approach. So, yeah, it was interesting for me, and again, now we will have more data from Nando, and I want also to raise this. I don't know if you guys know, but if you don't know, you will. The Percona Live is back, so hope to see. Yeah, we are back. We are back. There is the founder just on the corner there. If you want to have Percona Live Europe, just send email to him.
What for?
Well, you can say something about it. Because of course, not everybody can travel to US, and but it's the first step, right? And we are super excited to have Percona Live back here. And well, that's it. If you have any other question, I'm here. If there is no time, we can talk outside. This is a super summary of a lot of work. Just let me say that I just presented the top of the iceberg, and but there is a lot more behind. So if you want to dig a little bit more, just reach me out, and I will be more than happy to discuss with you. Thank you.